Alright everyone, in this video in our course I'm going to discuss adding and subtracting fractions. And in the video I'm going to outline 3 approaches that you can use when you're faced with a problem involving adding or subtracting fractions. Now as per usual, there are contents in the description if you want to skip ahead to any part. Now there is only really one big rule here, and that is we can only add or subtract fractions together if they have the same denominator. When we have different denominators, we'll have to do a little bit more work. Now when our fractions have the same denominator, we're just going to add or subtract the numbers on the numerator, and then we will leave the denominator value unchanged. So to demonstrate, if we had something like 3/4, so 3/4, plus 2/4, that's 2/4, we're going to add up the numerator terms. So 3 plus 2 is equal to 5. And we leave the denominator term as is. So that just stays at 4, 5/4. So that would be addition. If we had, say, 3/4 minus 2/4, so we had a subtraction, we would just subtract the numerators. So 3 minus 2, that's equal to 1. And again, we just leave that denominator value unchanged. That will be 1/4. And actually this makes a lot of sense. When the denominators are the same, we would be adding or subtracting the same sorts of things. So here we're adding and subtracting quarters. And we can see this point visually. So for instance, just thinking about our addition example, if we had 3/4 of a circle like that, plus 2/4 of a circle like that, in total we would just add up those shaded parts. 1, 2, 3, 4, 5/4 of a circle like that. If we were trying to add up 3/4 and 1/6, for instance, we couldn't collate them in this way. We can't add up quarters and sixths. They're different sorts of things. They're like apples and oranges. So a little more skill is needed when we add or subtract fractions which have different denominators. Let's think about a second example. What if we had 1/2, so 1/2 plus 3/4, 3/4. And really the trick here is that we're going to restate our fractions in our sum or in our subtraction in such a way that their denominators are equal to one another. And we do this by transforming either or both or all of our fractions into what we call an equivalent fraction. Now, equivalent fractions are fractions that have the same value as one another. For instance, if we had 1/2, 1/2, and 2/4, 2/4, they are both equal to the value 0.5. They are equivalent to one another then. And we can see this visually if we like to. If we look to our circles, 1/2 of a circle, 1/2, is just 1 part of 2. And 2/4 is here, it's 2/4. And hopefully you can appreciate that in both cases, the same proportion of the circle is being colored in. This is another way of showing that 1/2 and 2/4 are equivalent in value. So what we need then to solve our sum in our second example here is to find equivalent fractions so that all of our fractions in our sum have the same denominator, and then we can add them easily. Now there are a few strategies that we can use to find equivalent fractions. In this video, I'm going to go through 3 strategies. So strategy number 1, we're going to check if one denominator is a factor of the other denominator. And we saw what factors were in the previous video in this course. If you saw it, a factor is a number that divides a given number evenly or exactly, leaving no remainder. For instance, if you remember from that previous video, the factors of 4 are 1, 2, and 4. Since 1 times 4 is 4 and 2 times 2 is equal to 4. So we can see that just bringing that back to the definition, 1, 4, and 2 divide into 4 and leave no remainder. So 4/4 is 1, 4 divided by 1 is 4, and 4 divided by 2 is equal to 2. So then if we have a look at example number 2, our second example, we have 1/2 plus 3/4. Looking at the denominators, I can see that 2, that's the denominator of the first term, is a factor of 4, the denominator of the second term. And if you recall specifically, it's 2 times 2 is equal to 4. So what I'm going to do then is I'm actually going to multiply both the numerator and the denominator of 1 over 2 by 2, like that. And what this is going to do is this is going to give us an equivalent fraction with 4 on the denominator. So I'll show you just on the top, 1 times 2 is 2. And on the bottom, 2 times 2 is 4. So we get 2 over 4, and the sum is now 2 over 4 plus 3 over 4, which we actually saw that before. 2 plus 3 is 5 over 4. And just to be clear, when we're multiplying the numerator by 2 as well, this basically makes sure that the actual value of our fraction does not change. So 2 over 2 is equal to 1. So we're multiplying 1 over 2 by 1. So we're not changing the value of 1 over 2, but we are changing the way that that value is being expressed. We're making an equivalent fraction, and that's an equivalent fraction that's more useful for us. All right, let's think about a second strategy, which is to find what we call our lowest or our least common multiple, and we can notate that LCM. We find the least common multiple of our denominators in our sum. Now, this strategy is appropriate when there is no denominator that is a factor of the other. Now, our least common multiple, just thinking about if we're adding or subtracting two terms, it will be the smallest whole number or integer that is divisible by both denominators evenly without remainder. So for instance, if our denominators were 8 and 12, the least common multiple of 8 and 12 is actually 24, since 24 is the smallest whole number that is divisible by both 8 and 12 without remainder. So 24 divided by 8 is equal to 3, and 24 divided by 12 is equal to 2. There's really no other smaller number smaller than 24 that 8 and 12 both divide into evenly without remainder. And so we can use this information to help us with our sums and our subtractions of our fractions. So let's consider a third example. Let's say we had 5 over 8 plus 7 over 12. Now we saw before that our least common multiple of 8 and 12 is 24. And specifically, we're going to multiply 8 by 3 to get 24 and 12 by 2 to get 24. So what we're going to do is we're going to find equivalent fractions for both of our terms here where the denominator is 24. So we can multiply 5 over 8 by 3 over 3 and 7 over 12 by 2 over 2. And this should give us two equivalent fractions with that denominator of 24. So 5 over 8 times 3 over 3 is equal to, well, 5 times 3 is 15, 8 times 3 is 24. And 7 over 12 times 2 over 2 is equal to, well, 7 times 2 is 14, and 12 times 2 is 24. And we can now add these fractions together because they have the same denominators. So 14 plus 15 is equal to 29, and that's over 24, and that's our answer. Now, remember that 3 over 3 and 2 over 2, they're really just equal to 1. So when we're multiplying 5 over 8 and 7 over 12 by these terms, we're not changing the value of these fractions at all. We're just changing how that value is expressed. Now, the third strategy is to multiply the numerator and denominator of each of our fractions, so each of our terms, with the denominator of the other fraction, the other term, if that makes sense. So this is a quicker, yet it will be most often a less elegant approach to our sums and our subtractions, but this approach will always work in any situation. So it is a super useful one to understand. You don't need to think too hard. That's why it's quick. So for instance, let's demonstrate this approach on that third example that we just went through. So we thought about 5 over 8 plus 7 over 12. What I'm going to do is I'm going to multiply 5 over 8, that's our first term, our first fraction, by 12 over 12, because 12 is the denominator of that second fraction. And I'm going to multiply 7 over 12 by 8 over 8, because 8 is the denominator of that first fraction. And I get, well, 5 times 12 is equal to 60, and 8 times 12 is 96, plus 7 times 8 is 56, and 12 times 8 is 96. So we have two equivalent fractions with the same denominator. 60 plus 56 is 116, and that's over 96. Now, with this answer, 116 is actually 29 times 4, and 96 is actually 24 times 4. So we can cancel out 4s here, and we're left with 29 over 24, which, if you remember, is the same answer that we got before using that second strategy. So you can see that the third strategy here is not so elegant though, because we kind of have to par down the answer at the end, but we do get the right answer, and this is a strategy that you can use in any situation. So that's our 3 strategies that we can use when we want to find equivalent fractions so that we can add or subtract fractions with different denominators. We thought about factors, we thought about least common multiple, and then we had our third easiest approach where we just multiplied everything out by the denominator of the other term. Now, there may be more strategies that I haven't gone through. There are often lots of ways to approach different problems in maths, but those are the 3 strategies that I use, so hopefully they help you. Now, one last point to mention is that this all works backwards. So just to review, we've seen that as long as the denominators are equal, we can add or subtract the numerators, but we leave the denominator value as is. Now, this means that if we're given a fraction that has an additional or subtraction on the numerator, it's possible, and sometimes best, depending on the context, to split that term up into 2 or more fractions. For instance, if we had 12 plus 3a over 4, we can rewrite this as 12 over 4 plus 3a over 4. And actually 12 over 4 is 3, so this reduces to 3 plus 3a over 4. And this is really our rule, just working backwards. And just to be really, really clear, if there's an addition or a subtraction on the denominator, we can't do the same thing. So like 4 over 12 plus 3a does not equal to 4 over 12 plus 4 over 3a. Now, I will say, just to end, success with this and all of the maths really is absolutely about practice. Now, for some people, I understand that there is a lot in this video, and we've already actually been through so much in this course already. There's new concepts and new skills, but you can absolutely get through it once you understand the concepts with practice and repetition of these skills and rules. You can get really good at it. Now, if you would like written notes to help you on your journey, or even just to support this channel to help me make more videos, you can buy the accompanying notes to this course. It should be my shopping banner below. I hope that these videos are helpful for you though. If they do help, please like and subscribe, comment below, share all of that. It all helps. Any feedback also is super welcome. Thanks everyone. I hope you guys are having a great day.